a channel.
Yeah, but how can I access it?
Yes, I will send you the link. Yeah.
Okay.
It's in the chat. It's actually in the chat.
Yeah, I also want to have a try.
Okay, it should be up, Henry. Oh, I hear you.
Yes, I see. Yes, I can see.
You know, actually, I changed computer. I changed earphone. I changed the network. Changed everything.
Yeah, these things are tricky, right? When you're remote, it's very different.
I'm going to send you the link.
So Professor Shu, I see your notes on the screen. Oh, because you don't have a presentation mode. That's why. Okay.
Yeah, that's a note. That's a note. But when I give the presentation, people will not see it. Yeah, it's fine. Yeah.
Okay. Do you
Yeah.
want to just put it in, what you call it, presentation mode now? So when people join, they see that. That'd be great. And they see you. And unfortunately, me.
That's fine.
Wonderful.
Uh-huh. Yeah, the YouTube link. If I stop sharing, then what can I see in the YouTube? Nothing?
Let's see. Have you tried
Oh,
out
no.
the YouTube link?
Oh, we still can see. Yeah.
Yeah. Yeah.
Hi, Gerhard.
Hi, good evening.
How are you this evening?
Hi.
Good, thanks.
Good, 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 good. All right, seems like we have everything working today, so that's a good thing.
That's good.
Yeah. Now feel free to multitask all you need for the next whatever, 10 minutes. We're ready to go. So Gerhard, you'll do the intro, right?
Yeah.
Okay, great. Great. And then Henry, we don't have our next webinar set yet, right? That's still pending?
No, because I'm asking Ricardo to contact Victor.
Okay.
Just because the professor in India did not reply to my email, and that's why I'm asking Ricardo, see whether he can help out. Yeah.
Okay. Okay.
No problem. I will ask Ricardo again. Yeah.
No, I'm not rushing. I was just wondering if we could introduce it here, but that's okay.
Yeah, yeah. And actually, I want to. But
yeah. Right.
Yeah.
Okay. All right. I'm gonna go check my email, make sure nothing's blowing up with the WebEx. I'll be back.
Yeah. Are you still in your university?
Yeah, I'm in the office.
Okay.
Are you still in your office?
Yeah, I used to work.
Okay, so you're just on the corridor then. That's good.
I'm sorry, I'm talking to myself. Professor Shu, would you mind putting up your presentation again? Just so people know where they're landing?
Okay.
Thank you. Excellent, thanks. Okay, and I will be back in 2 minutes. I'm gonna go get a cup of coffee.
Okay. Oh, it's morning.
It is morning, yes, yes.
Coffee.
It's so funny, right? How can that be? I'll be right back.
Gerhard, will you introduce my short bio or?
Your short bio was slightly shorter than a minute, so I just made it a little bit longer. But it's just about a minute or slightly more than a minute.
Okay. Okay.
But it's basically just where you work now, where you study, what your interests are, and some IEEE things you're currently doing. But it's quite short. It's like a minute
Okay.
or a minute and a half. Yeah.
Okay, that's fine. That's fine. Yeah. Thanks a lot. Yeah.
Professor Su, thanks for accepting our invitation. I know you are quite busy.
Now
now,
we're busy.
Yeah, EIC of a journal, then must be very, very busy.
Now I'm very busy.
Yeah.
EIC.
Yes. Because a few years ago, I was also in EIC of a journal. Then every day I had to handle a lot of papers and, complaints, in particular.
Normal.
Almost, people who complain. Yeah.
But these two journals are relatively small.
Yeah.
One is new, but new does not mean not busy.
Oh, still,
New
yeah,
journal means more busy.
Yeah, you
Lot
have
of
to
things
handle
do.
lots of things. Yeah.
Yeah.
Make a decision. Yeah, and also make sure that the turnaround time is short.
Yes. Also, I'm also serving for quite a few IEEE journals. You have know
Oh.
that. I got a lot of assignments from the Professor Renlo.
Yeah.
TII.
TII, yeah. Informatics, right?
Yeah. Thanks a lot for the invitation. I think this is very good. Very good.
Yeah, this is the second time we organize this, and we hope we can set up this webinar series, and then let more people know more about IoTs. I mean, from different domains, right? Different domains.
Yeah. My domain now is in agriculture IoT.
Okay, interesting, right?
Yeah. Yeah. Previously, I was not in this domain.
Oh.
Yeah. But after joining this university, Nanjing Agricultural University, I started to change into agriculture-related research work.
Okay. And I watch TV and see that there are many projects in mainland using the IoT for agriculture. Quite a lot. And the integration of renewable energy thing, it's quite advanced. The technology.
Now it's quite popular.
Yeah, quite popular.
Since the year of 2017.
Yeah.
Since the year of 2017, scientists in mainland, a few academicians, they mentioned the concept smart agriculture.
Okay.
That is 6 years later than industrial 4.0. They mentioned the agriculture 4.0. Industrial 4.0 was mentioned in 2011, but
Okay.
Agriculture 4.0 was mentioned in 2017,
Okay.
6 years later. So now it's a little bit hot
Okay.
for people in agriculture-related universities.
Then what is agriculture 3.0, 2.0? You know, for industry 4.0 is quite clear cut with that, you know, the automation thing, and then later with, you know, the AI thing integrated. But how about agriculture 4.0? I mean, it's okay with 3.0.
I will talk about it, and today
Okay.
I will even create agriculture 5.0.
5.0, okay.
But actually, in a different perspective, yeah.
Okay.
Because they talk about agriculture 4.0 in the perspective for applying artificial intelligence and IoT, emerging IT technologies. But my perspective is in using the energy.
Okay, energy. Okay, that means integration of energy.
In terms of energy, in terms of energy, because agriculture production is always closely related to the using of energy. In terms of energy, we are in the fourth generation. No, the fifth. We are approaching the fifth generation.
Okay.
Yeah.
I read an article on let's see, I think it should be IEEE Spectrum talking about making use of sun energy, solar energy to generate hydrogen. Yeah, for future vehicles. Yeah, the hydrogen. And maybe it's the way, like solar, and then how do you make things sustainable? You know.
Yeah, that's one of the applications for solar power panel stations.
Yeah.
Because currently it's very difficult to store this kind of solar power generated energy.
Energy, yeah.
During not in the peak hour time, the generated energy probably cannot be fully utilized by the citizens. So sometimes it's a waste. Then people think that to create a new type of model to store this produced energy. So hydrogen, hydrogen is a very good way. Convert clean energy into chemical energy.
Yeah, the chemical energy. Yeah.
How about your research field?
My area is in power electronics, and in fact, I have done quite a lot of work on solar energy, but the power electronics, how to convert energy, like from solar energy, the output into DC or AC, that kind of thing. There is a power.
Okay.
And now right now I'm using AI thing for power converters as well. How to detect diagnose the condition of the converters, as well as batteries as well. Yeah, quite a lot work on that using AI.
I think your research results can be also applied in this new scenario.
Yeah. You know, it's important nowadays for the diagnosis. You know, in the old days, people consider only the performance or the this kind of thing, whether it's possible to convert energy from DC or solar energy into the AC or the power grid. But nowadays, people would like to know more things. Okay, in particular with the advancement in of the IoT technologies, then people would like to know more about the condition of like all those accessories, converters, batteries, solar panel, etc. Yeah.
Important to keep the reliability.
Exactly. Yeah, the reliability, and that's why we have just completed a project for the government, and we developed model that can detect the health condition of solar powered lampposts. Yeah, you know, the lamppost has the solar panel, batteries, and solar the LED lights. Then the module can give the real-time monitoring of the panels, batteries, converters, lamps, etc. And then through the LoRa gateway, and then sending the information back to the central control center. Yeah, that's the way. Yeah, that's what I'm now working on, because my background is power electronics, but you know, power electronics is only a part of it, only a device. But nowadays, with the advances in semiconductor microprocessor, then it would be great to integrate more things. Yeah, it's good.
Yeah, nice to know that. Just now you mentioned about the now that people are focusing on the performance.
Yeah.
I want to share with you an interesting point.
Yeah.
In agriculture university, in most agriculture university in China, mainland, people in agriculture engineering field, most of the people are focusing on increasing the production for agricultural food.
Yeah.
And after the emerging of smart agriculture or agriculture 4.0 vision, we started to use many IoT systems in agriculture field, but none of us thought about the security problem.
Yeah, security issue. Yeah, it's important.
It's the security problem. Yeah.
Yeah. Yeah. Yeah, I had a case. Yeah, a few years ago, I designed a module for the government, which is used to test the battery health condition. At the very beginning, we designed a wireless. The module is wireless. That means it's possible to send the data through the Wi-Fi. But somehow they said, "Oh no, don't use Wi-Fi, but hardwired," just because of the security.
Security, yes.
So they really keep using the wired connection.
But that's okay. That's okay if you use that thing in factory, but in in open field like hillsides for agricultural farmland, it's impossible to have wired-based communication.
Exactly.
Yeah, very interesting.
Yeah, it's very interesting. But somehow the government is promoting LoRa in Hong Kong. No, time.
How about the level of LoRa? Gerhard, do you know that?
Sorry?
How about the security?
Oh, okay. Good
LoRa.
question. Good question. It's a very good question. Yeah, we try to actually we have a gateway. The government gateway in the university. We are going to test it out. Yeah, see whether it's possible to break it.
That's one very important issue.
We should start getting ready for the webinar.
Yeah. This,
Mr. Shu, maybe can you get closer to the camera, or is it impossible?
It's fine.
Well, better.
Better.
Yeah, the picture is. Yeah, I really need to see the YouTube output. Henry, can you paste? Thank you.
You see the YouTube link?
Did not see it. But you can tell me how I should adjust myself.
I see.
You get it? Oh, hey.
Yeah, I'm saying that I see myself. Ah, right. Okay. Now I see Mr. Shu.
Yeah.
Yeah, more or less it's okay.
It's offline. You know, where is George? Which country?
He's in Spain.
In Spain. Okay, in Spain.
Mhm.
How about you?
I'm in New Jersey. I'm in the US.
Yeah, you.
Yeah,
Okay.
we're all across the globe here.
Group here.
Okay. How about the
East-
weather in United States now?
Today it's going to be about 95 degrees Fahrenheit. It's hot.
Oh,
It's
yeah, it's
very
very hot.
hot, very humid. Summer is here. Yeah, how about there? Is it hot there too?
In China, no.
No?
It's raining outside. Today it's
Raining.
very cold.
Okay.
Yeah,
Oh.
very cold.
Okay. I guess I won't complain about the 95 and sunny today.
I read news about the recent extreme weather in United States, and they said many states in United States are suffering the extremely hot weather now.
Yeah, I think on the West Coast, it was like 111 degrees, which has never happened. It's scary.
So
It's
in that case, can people go outside?
barely, right? You run to your car, you run to the store, you run back. Yeah,
Okay.
today will be an inside day for sure. I'm working anyway, so it doesn't matter, but yeah, as long as the power stays on, we're good.
Okay.
Keep your
So
fingers
power station is very important. Okay.
All right, so it's 1 minute of, do you want to give people a couple extra minutes to join? We have 15 participants so far, and welcome everyone. What do you think? You want to give it a few minutes?
Yeah.
Okay. All right, nobody's having connection problems that I see, so.
Quite good today. Yeah, the connection.
Yeah.
Much better than yesterday.
Yeah, much better.
Yesterday was a little scary.
Yeah.
Welcome everyone. We're going to wait a few more minutes and then we'll get started. Thanks for joining.
Mhm.
And just a reminder also for the for the panelists, if you're not speaking, if you can just go on mute, that would be great.
Yeah. Okay.
Thank you. So quiet.
Please remember to tell the audience how to make questions, because we have two places to place questions, the Q&A section and the chat. I think it's better to focus on the chat.
Yeah, I do
Yeah,
too.
yeah, it would be great to have it on the chat.
So Gerhard, can you do that when you're doing the intro? Would you mind? Okay, great. All right, so what do you think? You ready to kick it off?
Okay.
All right, I'm gonna start recording.
Yeah, then we can start now. Okay. Good morning, good afternoon, and good evening, everybody. This is Henry, a member of the IEEE IoT Activities Board. On behalf of the board, welcome all of you to join today's webinar. The Internet of Things is one of the most exciting technological developments in the world today. And the key mission of the board is to promote IoT. Currently, we have 12 IEEE societies joined it. And with their support, we are going to organize this webinar series. Each month, we will have an exciting IoT topic. Today is the second one. We are very delighted to have Professor Shu to deliver an interesting topic related to the use of IoT in agriculture, and Dr. Gerhard to be our moderator. I hope you can all enjoy this webinar. If you have any questions, do feel free to type your questions in the chat box, and Professor Shu will address your raised questions. Now, I would like to pass the time to Gerhard. Thank you.
Thank you. It is my pleasure to introduce Professor Lei Shu for today's talk, Future Agriculture, Outlook of Photovoltaic Farms in the Internet of Things. He is currently a professor with Nanjing Agricultural University in China, and also the Lincoln Professor with the University of Lincoln in the United Kingdom, and the director of the NAU Lincoln Joint Research Center of Intelligent Engineering. He received a bachelor's degree in computer science from South Central University of Nationalities, China in 2002, his master's degree in computer engineering from Kyung-hee University in South Korea in 2005, and his PhD degree from the National University of Ireland, Galway in Ireland in 2010. After his PhD, he was a specially assigned researcher with Osaka University in Japan, before becoming vice director of the Guangdong Provincial Key Laboratory of Petrochemical Equipment Fault Diagnostics in China from 2013 to 2017. His main research fields include wireless sensor networks in Internet of Things, in which he has published over 400 papers in related conference journals and books. He is very active within the IEEE, currently serving as the chair of the IEEE Industrial Electronics Society's Technical Committee on Cloud and Wireless Systems for Industrial Application, and also as associate editor for the IEEE Transactions on Industrial Informatics, IEEE Network Magazine, IEEE Systems Journal, and IEEE Access. It is my pleasure to hand over now to Prof. Shu to commence his talk. Thank you.
Okay. Thanks a lot. Dear host, thanks a lot for your kind introduction, and thanks a lot for providing me the opportunity to present the research result of our team. I'm Professor Lei Shu from Nanjing Agricultural University and also Lincoln University in UK. And before starting tonight's presentation, I would like to invite you to look at this butterfly on the screen. I want to ask you what kind of thing you will think about it, butterfly. Actually, what I'm going to present tonight, I want to mention that the presented content in this talk probably can cause the butterfly effect in our research community, and probably will draw more and more attentions from the governments of different countries. So when you look at this butterfly, I guess you will think about the butterfly effect. At present, I'm working as a professor at Nanjing Agricultural University, so I would like to briefly introduce NAU. This university located in Nanjing City. It was the capital, the old capital of China back in 1940s. Before the new Chinese country established. And NAU is a very famous university in China in the field of agriculture, and it is one of the best agriculture university in the world. According to the latest rank, we are number 7 in the world based on the ranking in agriculture field. And I'm also serving as a Lincoln professor, which is an honorable professor in the University of Lincoln. And if you look at the map, you will see Lincoln is located in the middle of UK, and it's inside a small city. However, Lincoln is also a university with very long history, more than 100. And currently, I'm establishing a joint research center, which is called the NAU Lincoln Joint Research Center for Intelligent Engineering. And as always, I think this is also a very good opportunity. We are continuously recruiting talented researchers to join us. And if you are interested in working in China, you are welcome to contact me after this presentation. Okay, to start today's presentation, I would like to kindly invite you to think about the question for a few seconds. What will agriculture be in the future? What will people, how will people produce food after 10 years? And probably what kind of factors we are facing at present for producing food? I want you to think about this question for a few seconds. And then let's look at this slide. Originally, I have a video clip here to help you to obtain the intuitive impression about the challenges about the traditional agriculture, but due to the limitation of the network bandwidth, I cannot share the audio sound from the video, so I deleted that slide. But still, you can see from this picture, currently we are facing at least 3 major factors, 3 major challenges for our traditional agricultural production, which is extreme weather, population explosion, and urbanizations. And all these 3 factors, they work together and make the situation become worse and worse. And probably I believe I don't need to mention more explanations. You will think about one more challenges, which is I think the biggest problem that we're facing in our daily life, the coronavirus pandemic. Okay, that problem definitely will affect the agricultural production in the future. So we can look at a little bit of detailed data about pollution explosion. If you join me to look at this table 1, you will see that according to the prediction from United Nations, to 2050 to 2050, we probably will have more than 9 billion people on the Earth, and the majority part for the increment came from Asia and Africa, and especially in Asia from India and China. So It is still an open question for all the scientists and for all the government in the on the earth. We don't know whether we have enough food to support this many people by 2050. It's a huge challenge for us. We don't know whether we will have enough food to feed ourselves. In terms of natural disaster, probably today in our audience, we have many friends from North America. I just talked with Karen. Nowadays, a lot of people in North America are suffering the extreme hot weather. And not only their daily life, I believe not only their daily life is severely affected by this kind of natural disaster, but also the local agriculture production is affected. If you look at the different kind of news, you will read about it. And many people actually said natural disasters are unpredictable and uncontrollable. But if we look at the natural disaster happened in the past of few years, we will see that, okay, it actually happened as a pattern. And this kind of disaster increasing year by year. For example, if you look at this map, as I show in my slide, back in 2017, in China, almost half of China suffered very serious natural disasters, and most of these this kind of counted disasters caused direct economic losses greater than 500 million RMB. And in terms of urbanization, according to the data from Chinese Bureau of Statistics, we got the data from 1997 to 2015. More and more people are moving from rural area to modern cities, and a lot of cultivated land were used for urbanization. So we will have this kind of question: who will cultivate land? Who will cultivate where to produce our food? So this kind of difficult situation actually motivated the government and the researchers to explore different kinds of alternative approaches for producing more food by applying various new emerging technologies and smart robot. In that sense, people are exploring the vision as smart agriculture. Okay, in the past few slides, I think we understood the current difficulties and the current situations, the challenges in our traditional agriculture. And now I want to invite you to answer this question: what kind of car is this? Okay. Since now we are having online streaming presentation, we probably can have very limited interaction with audience. So I'm telling you the answer. It is a new type vehicle, Tesla. Okay, this kind of vehicle use renewable energy, electricity. Then I guess you will ask another question back to me. Why do you jump to Why do you suddenly jump to Tesla in this presentation? Will we use Tesla in our agricultural production? Probably, I guess you will ask this question. I will not give you answer now. I want to invite you to follow me to see my following slides. And before answering your question, I would like to ask one more question. What new energy vehicle, why new energy vehicle be used? Okay, I guess the answer is quite obvious because we are trying our best to find a sustainable way to overcome the depletion of petrochemical energy. And we are trying to find a way to satisfy the continuous growing demand on energy. And also we are trying to find a good way to protect our Earth by reducing the emission of greenhouse gas. Okay. And also we are trying to avoid to increase this kind of situations for starving or various kinds of natural disasters. So that's the reason why we started to think about to use new type of vehicles. We're protecting the Earth. In terms of energy demand, I want to invite you to further join me to look at these a few tables. In this slides, you will be able to see more concrete information about the demand on energy in our daily life and the number of private cars in China. If you look at the figure 4, you will be able to see the number of private cars inside China. You will have the number that we have for 2016. That is just for private car. We do not count the public car. For example, the car for public transportation, for taxi, for bus, that kind of type of car we do not count it here. Now we are in 2021. Now in China, we have even more private cars. Okay, that's a huge number. You probably think why I mentioned this number. Okay, I will let you know why I mentioned this number. And if you look at this figure 5, you will surprisingly discover one thing with me. We are using more and more energy. We're using more and more energy in each year. We are using more energy than what we consumed in last year. I don't know why. Okay. Probably we are using more computers. Probably we are using more cell phones, or probably we are using more powerful air conditioners. Okay. But we are consuming more energy in our daily life. And if you look at this table 2, you will be able to see a timetable. This is a timetable that had already been released by several countries. Okay, this timetable shows the deadline for stop producing traditional vehicles. Okay, which means that, for example, in Norway, after 2025, they will not produce any more traditional vehicles. They will have only electricity powered vehicles. So we are having serious growing, heavily growing energy demand. Then we need to think about how to face the growing energy demand. Then, of course, we will look at the new energy resource. And I think now we already had a very clear image about what kind of new energy resource we have: solar power, hydropower, wind power, nuclear power, and also photovoltaic power. Among all these different kind of power sources, we can simply compare them, and you can easily get the conclusion that photovoltaic power probably is the ideal one, the ideal candidate, because it can be easily deployed, and it can be easily deployed beside your living environment, not a place very far away. Okay, and if you think about the wind power, you won't always have the condition to have wind power beside your city. And for nuclear power, probably you got the lesson that what already happened in Japan. Probably you want to use nuclear power, but you don't want to have a nuclear power station built beside your city. So for photovoltaic power, this kind of resource is clean and it's cheap. It can be easily distributed in our living environment, and we consider this one is a very important energy resource. Now, to this step, we got one very extreme idea and a very extreme question. How about we use only photovoltaic power to support all the new type of vehicles, all the new type of cars that use electricity? For example, just in China. Okay, then how large the size of the power station should be? So we get this kind of calculation. Okay, we think that we built PV power station in a location with 40 degrees north latitude, which is actually quite similar to the latitude of Beijing. And we calculated the size of the PV power station to support all the vehicles, private cars, okay, based on the number that we got for 2018. And surprisingly, we got the size. Okay, it is 27,500 square meters. Probably you have no idea about this size. Okay, when I got this number, I have no idea about this size, and then I have to calculate the area of Beijing and Tianjin, two very big city of China, and I realized that this size actually equal to the size if you combine Beijing and Tianjin. If you have never visited Beijing and Tianjin, and happily you visit New York, and this size actually means 14.5 of the size, 14.5 times of size of New York City. So if you look at this size, to this point, I think you won't think about it as a PV power station. Okay, you will join me, and you will think about it as a photovoltaic ocean. And then to this point, I believe that you can answer the question you just raised. Okay, you asked me why I joined jump to Tesla, and why I present Tesla in a presentation related to agriculture. Okay, and the answer, yes, it is about land competition. We surprisingly found that we have land competition not just in urbanization. We even got this kind of competition from energy industry. Okay, then the question is, how can our Earth offer this? How can our Earth have enough land to support all these demands? We have problems for population, climate, and we have problems for energy and agriculture, and then eventually convert into land. Any good idea? I want to ask you to join me to think about this. Okay, probably some of you will think about a very good question. We can migrate to Mars. Okay, we can go to another planet, but we cannot realize it quickly. So I gave you the answer in my presentation. We can have a new type of agriculture producing mode, which is called photovoltaic agriculture. The basic idea is to build another solar power panel layer above the farmland to allow one piece of farmland can receive double incomes. Okay, one from the generated electricity and another one from the cultivated crops. Here I want to mention that we are not the first scientist or first research team to mention or propose this. Okay, to the best of our knowledge, this concept was actually proposed in 1982, the first paper. But this concept did not receive enough attention until recent years. Okay, just recently, scientists started to consider about this. And for what agriculture is actually a promising solution, it can increasing both the land use efficiency and the share of renewable energy provided by the agricultural sector. And new energy company, they can use farmland to build up power generation stations without changing the original purpose of the land. Okay, and it can even protect the environment, and it can even draw more tourism for sightseeing. And if you look at these few pictures, you will immediately realize that photovoltaic agriculture had already been developed in many countries. And inside of this table, you will see that at least in these listed countries, scientists had already carried out successful experiments and established the new photovoltaic agricultural farmland. If you look at the one in UK, you will see that the electricity from solar is not only used for lighting, forage, mechanization, management, and forage processing, but also satisfying the energy needs about 6,000 local households. Okay. I want to mention that brilliantly. Okay. Israel is the country, the first one. They developed this photovoltaic agricultural farmland in the world. And the first one that was built in China was in 2017. The first one was in 2017. So just 3.5 years back. And also, depending on different countries' local situation, the photovoltaic farmland was developed in different directions. For example, in Europe, the PV pasture is a common mode. Okay, in UK, in Austria, in Germany, Israel, in China, Chinese government use it as a method for alleviating poverty in rural area. They use this kind of method to create more jobs, to allow people to work, to help to maintain the working status of the solar power stations. Okay, I think to this step, we already got a very clear image about the photovoltaic agricultural farmland. And in order to realize it, there are at least 4 aspects we need to consider in order to provide a high quality PA farmland. Okay. The first one is we need to have a new type of drip irrigation system. I will explain this in the following slide. The second one, we need to consider about a good networking system for collecting agricultural production related information. The third one is we need to have a good monitoring system to maintain the reliability of this solar power panel. The fourth one, which is also very important, is in different field. It's basically in life science, not in computer science. We need to explore the diversity of species. Okay, this means that we need to explore the diversity of different kind of crops, vegetables that can be planted under the panel. And obviously, in this kind of working scenario, to have a high quality PA farmland, we have to combine. We have to use various kinds of sensors, and we have to combine the concept photovoltaic agriculture with Internet of Things. We need to apply Internet of Things into this field. So which allows us to generate a new term, which is called photovoltaic agriculture Internet of Things. Okay. And you can see that we can get the different kind of sensor informations, and by having wireless communications or wire-based, but mostly wireless communication-based, and we can have AI-based technologies to produce better applications. And to that step, we search the keyword, which is PA IoT. Okay, we searched the keyword, and we conducted a very solid survey work to understand what had already been done in the past few years by academic community. And we found that, we found that there is no related scientific activities in the field of computer science. No computer scientists were involved in this field so far. No, probably maybe we have some after we publish the papers. And most of the published papers before 2019 were in the field of energy. And the paper were mainly presenting the concepts or were evaluating the economic impact. Okay, but yes, of course, the impact is good. Okay, it proves that applying this kind of technology can bring more income. Then my research team started to investigate this area and also the related research issues in 2019. And we published the first paper in this area, which we defined PAIoT, Photovoltaic Agriculture Internet of Things. If you are interested in, you can go to IEEE Access to download this paper to have read. It's an open publication. So we also give a clear definition about PAIoT. It's a system actually can collect the on-site information to on production area about the field planting facility, gathering, livestock, poultry farming. Also, all the sensors and the device were installed on the steel structure bracket. And most importantly, the sensor node can be supported by the PV power station, not powered by a battery. Okay, and we can use multi-scale reliable transmission to transmit the gathered data by using modern transmission technologies. And also inside of the system, we need to have data fusion and the data processing, and intelligent decisions and unwalling should be there for the agricultural production. So if you look at this picture, you will see two different layers. Okay, there will be an upper layer and a lower layer. For the lower layer, the various sensors we probably will bury in under the underground, and a lot of sensors will be deployed in the upper layer to gather the information about the solar power panel, also information about the growth crops. I'm also presenting the layer-based architecture of PAIoT. Basically, we will have 3 layers: perception layer, transport layer, and application layer. Here, I did not divide the fog or edge computing into a different layer. I put it into the application layer. In the perception layer, we will have many different kind of sensors to allow us to gather to different kind of data, and we can utilize modern wireless communication, communication technologies, for example, Zigbee, Wi-Fi, or cellular mobile communication technologies to transfer the gathered data back to the center. And inside the application layer, we will have interdisciplinary deep integration. Basically, we will have things for diagnosis. We need to think about what kind of plant we can cultivate under the panel. We need to think about interference for wireless communications. We need to think about what kind of robot we can use to clean the solar power panel. Many interesting research issues. Probably audience will ask me the question, what's the difference between PA IoT with other traditional agriculture IoT? Traditional agriculture IoT, one we call is we apply sensors in a large field open agricultural farmland. Another one is the facility-based greenhouse IoT. So the PA IoT, the applied field is very different from those two, and the network coverage is also very different depending on the construction, depending the needed size. Also, the number of deployed nodes inside the different three scenarios are different. For traditional agriculture IoT, the nodes were spatially deployed. For greenhouse IoT, we have normal number sensor nodes, but in PA IoT, nodes were densely deployed. And also the power supply is different. And in terms of power PV module status monitoring, for two traditional IoTs, we don't have that. And also we don't have that kind of so-called electromagnetic interference. But in PA IoT, we do have that. And the deployment cost is different. For traditional agriculture IoT, in order to deploy sensors into the field, we need to purchase the bracket, and we need to find a way to protect it. And in greenhouse IoT, in that scenario, we can put those sensor nodes on the greenhouse bracket, which means the cost for deployment is lower, it's much lower. And it's the same, because in PA IoT, we also have the bracket for PV electric field. And in terms of collecting image information for agricultural production, in traditional IoT, there are many different ways, but in greenhouse and the PA IoT, we have limited ways. Okay, mostly we need to based on the local cameras. Also, probably you know that remote sensing technology is widely used in agriculture, in various applications in agriculture. We can use satellite, we can use drone, we can use UAV to get this kind of crop information. But in greenhouse IoT based case or PA IoT based case, we cannot. We cannot use remote sensing technology, and we cannot use UAV to get the image. So these are major differences here. In terms of research challenge issues inside of PA IoT, the first one, we need to think about the sensor network deployment, which means that the node deployment. There are many constraints. I can list the 6 constraints here, and I will introduce these constraints in the following slide. In this slide, you will see a grid. Assuming this grid is a 200 meter multiply 200 meter size, okay, a farmland. And inside of this farmland, we need to deploy many sensor nodes. For example, camera node, and you will see the green node. That pattern, we need to deploy the camera node based on that pattern. About the soil monitoring node, we deploy the one as the yellow one. And about the insect lamp, this is a new type of probably very, I don't know whether you know it, it's a kind of green equipment to kill insects. Okay, we can deploy at least 9 node here. But if we merge all these kind of device into the same line, we'll get something like this. Okay, and probably you will think about the question. Probably we can combine some of these nodes, some of these devices into one to reduce the hardware cost. And this actually motivated new research problems. How do we, in what kind of situations, we merge these nodes? Because if you go to the market, you cannot buy this kind of merged node. Definitely cannot find one over there. And also, as I mentioned earlier, in this scenario, we have electromagnetic interference. And this kind of interference caused not only by extreme weather, but also by the power generation from the solar power panel. So we need to think about how to overcome this kind of interference to provide reliable data transmission. So there will be a research point to build up for tolerant configurations to think about the different transmission time to avoid this kind of interference. And in terms of the transmission of the gathered image, there are also issues we need to consider because the deployed node can be on very irregular farmland, and there probably will be some bottleneck problem over there. And we need to consider how to find out the bandwidth between the sampling frequency of this gathered image and also the limited network bandwidth. Especially in some spatial time period, we need to increase the sampling rate about the gathered image for harvesting some spatial crops, for example, chrysanthemum flowers. This is the one I just mentioned here. The chrysanthemum flowers can be used for medical purpose, but also for daily health purpose. It can be used for tea. I don't know whether you drink it before, but it's kind of popular in China. And to harvest this kind of flower, we cannot wait until this chrysanthemum be fully bloomed. Okay, the flower should be open like 2/3 the status, and it should be harvested. And then during this time period, we need to have very high high image harvesting rate, sampling rate. to get a more image. But we also need to find the bandwidth. Okay, so in this kind of scenario, we will need to, based on the life pattern of this flower, to know when will be the best time to increase the sampling rate, and how high the sampling rate we can increase according to the available network bandwidth. Also, as I mentioned, in this scenario, we need to have for diagnosis, we need to monitor the fault of the PV module. We can deploy sensors over there to monitor the voltage and current, to understand the status of this solar power station. And using only sensors probably not enough, and sometimes we need to use UAV to capture the change in color of the solar power panel, to understand whether certain panel got problem or certain panel need to be washed. As I mentioned that the solar power panel should be washed, we come to one very interesting research problem. The drip irrigation system, the automatic irrigation system. Automatic irrigation system is actually a popular research topic and had already been studied in agriculture-related universities for many years. But in this scenario, we need to think about the case. We need to wash this solar power panel from time to time. Okay, in desert, probably we cannot wash it because we don't have that much water. But in certain area like where I'm living now, the Middle Eastern part of China, we regularly have the rain, and this kind of rain can cause some kind of small pot with dust on the surface. If you have your car, and you will see similar things after having the rain. Okay, so the solar power panel should be regularly washed, and this can be a problem. If we need to wash it, then how do we optimize the water consumption? How do we control the water irrigation for the crops under the panel? Okay, now we don't have this kind of automatic irrigation system at all. Okay, all the systems are separated. We have clean robot. Clean robot is different. Clean robot is not linked with drip irrigation systems at this moment. So this is a new field which requires more researchers to get into. And we come to the slide, we need to think about the diversity. It's very interesting about the temperature. Some researchers carry out experiments. They discovered that the temperature inside of the PV power station, if the temperature inside the PV power station under the panel, the temperature is lower than the temperature outside of the station, especially underground. And then above the panel, around 2 meters, the temperature inside is higher. And when it reaches to 10 meters, the temperature inside is lower. Okay, so this kind of temperature actually can create very different regional microclimate. And for life science, for scientists in the life science field, they need to think about what kind of crops, what kind of plants, what kind of vegetables they can plant over there in order to maximize the income. Also, there will be some kind of requirement on the monitoring system in the IoT system. In terms of agriculture, artificial intelligence can be applied in all the sectors of agricultural applications. For example, crop cultivation, livestock, all these kind of things. And if we combine AI into photovoltaic agriculture, we can see that we can design smart robots. We can have a smarter way to control the insect. We can have a smarter way to optimize the using of the water in terms of the prediction for rainfall or in terms of the coming extreme weather. So AI technologies can also be applied in this scenario, and there are a lot of research issues over there. Okay. Remember that the topic, the question we asked at the very beginning is what our agriculture will be in the future. In 2018, inside China, we have a very famous professor called Xu Luo. He gave a talk in a joint international conference on smart agriculture and biorobotics. He defined the generations about the agriculture in terms of agricultural machine. So in his definition, the agriculture machine generation 1, the first generation, is human and animal power are replaced by machine. And in generation 2, to achieve full mechanization, in generation 3, to improve the level of agricultural mechanization by information technology. And in his generation 4, to realize agricultural machine automation and intelligence. Here, he actually combined AI into agricultural machine. And probably you all know that we have Industrial 4.0. And in this slide, we also give a definition about agriculture 4.0 and agriculture 5.0, okay, the 5th generation. Actually, when I listened to Professor Xu Luo's presentation about his definition on the agricultural machine generations, that time I got the question, what will be the 5th generation for agriculture machine? I don't know the answer. Okay, that can be something I think very difficult to answer. Okay, and before today's presentation, I had the chance to have a little discussion with Professor Henry. about the agriculture 4.0 definition. I don't know whether you know that actually in human being history, we have agriculture 1.0 much earlier than industrial 1.0, because agriculture is a basic industry for human being. But the industrial 4.0 was mentioned in 2011, and the agriculture 4.0 was mentioned in 2017, 7 years later than industrial 4.0. Okay, that definition was given in terms of the IT technologies, emerging IT technologies. In this presentation, in my presentation, I want to give you a different kind of definition in terms of the energy that we used in our human being history. So we can see that the coordinate, the x1, the bottom line. At the very beginning, we use firewood, and then we have coal, then we have petrol, and then we have traditional power, and then we have new type of energy, for example, solar energy and wind power. And we combine this new type of energy with agriculture, and we define it as agriculture 5.0. Okay, new type of energy, agriculture. And then after having this, I also ask myself a question: what will be the sixth generation after this? Okay, in our daily life, we can see facility agriculture. That is what we are having now. And what will be agriculture 6.0? I don't know. Okay, remember that we mentioned probably we eventually need to migrate to Mars. So probably in the future we will have space farming. And we got these pictures in a very famous movie. I think you already recognize it. As I mentioned, I deleted 2 video clips from my presentation material. Probably you can download the presentation from my provided link, and you will see another very interesting video clip to let you to understand the concept about the future agriculture, especially space agriculture. I want to say one more sentence. The exploration of our human being to the open space will never stop. So agriculture will always follow human being steps, and we will go to space eventually. So that probably is my answer for my own question: what will the agriculture be in the future? Thank you.
Thank you, Lei. Thank you for the talk. At this stage, we have a couple of minutes for questions. So if you have any questions, please put them in the chat. Maybe I can ask a question to start off with. So once again, thank you for your talk. I think the basic idea is very interesting, and I think most people can realize that the land, we have finite land, and the idea of mixing the two together, having this combined agricultural and energy system has clear benefit. But at the same time, you mentioned this idea was already mentioned, many decades ago. So in your view, what at this moment is preventing this idea from happening, on a large scale? Is there like a specific technical problem we need to solve first? Or is it just a case of deploying some of these things and then getting value added benefits out of it. So putting the machine learning and the IoT and everything on top of it and showing people that it could work really well, and then it will get adopted. What is your view on that?
Yeah, good question. Actually, back in 1980s, that time period, the energy harvesting efficiency on the solar power panel was not good. So that time, people did not think about to create a large scale solar power stations. Just recently, we had I think people slowly started to realize that we need to have new type of energy resource, and the people started to look into this sector, and the efficiency for converting the solar energy into electricity was increased, and so that kind of obstacle was removed. Then people started to look into this possibility to build up power station as well as the farmland.
Okay, thank you.
Yeah.
Okay, so there's another question coming in from Jose.
I can see.
So you can answer, I think, but I think for the people on YouTube, should I read the question or do you want to repeat the question just so that he knows what he's going to ask? So I'll pose the question to you. So there's almost no mention of smart grids, something I find surprising given that batteries and distributed micro generations are in place. Please, could you explain the relevance of smart grids in this new energy architecture?
Let me look at this one. Could you explain the relevance of smart grid in new energy agriculture? I don't really know what kind of smart grid that you are mentioning, but I noticed that you mentioned microgrid, right? Yeah, microgrid, distributed micro generation, and that one is actually the very basic concept for realizing this photovoltaic agriculture. We won't be able to have very large scale photovoltaic power generation plant in small village, small area, but that one can generate the power to supply the energy for the local village, for the local people, and can create jobs for the local farmers. So in China, this kind of micro grid actually was used as a method to elevate the poverty. If we consider larger scale, probably that is not the we do have this kind of large scale photovoltaic agriculture, but not in my current living area. We have that kind of PA farmland in the west north part of China, in Yinchuan, in Ningxia province, because that area we have many low quality farmland. The soil quality is not very good, and basically that land was used to previously was used for nothing, but people started to use for photovoltaic power generation, and then after a few years, people found that the humidity of the soil is get better and the grass can grow. And then the people think about, we probably can plant something over there to increase income. That's a different thing. Okay, let me think about another question.
So should we move on to the next question?
Yeah.
Okay.
Intensive vertical indoor hydroponic-based vegetable production were imposed over intensive vertical indoor. Probably, actually, Harry discussed with me about this before the presentation. Yeah, I guess probably the PA agriculture. I don't know. I cannot say. I cannot see the answer because I feel that I still don't have the knowledge to answer this one. It is beyond my background. How could I get a slide and the replay? You can download the slide from my provided link. I will provide a link after this. Or probably Karen can provide the link of the slide after this presentation.
Yes, I will definitely do that. Thank you.
Yeah. Let me check. Yeah, that's email.
Yeah, and I think also for the guys who have asked the two questions, if you want to discuss it with Prof. Shu further, then he's happy to do so, right? So you can take it offline with him also after the talk,
sure.
or in
After
future.
talk.
Yeah.
Okay.
So then it's good. Okay, then I think at this stage there's no further questions. So thank you again for the very interesting talk. Thank you for all the organizers. Thank you, Henry, Jose, Karen, for setting everything up. And please keep an eye out for future IoT activity boards, webinars for talks like this. And thank you for everyone for attending. Thank you. Thank you for everyone for attending. Thank you.
Thank you.
Thank you very much.
Yes, thank you very, very much. Appreciate it. It went really well.
Okay. Thanks a lot for the opportunity.
Thank you very much.
All right, have a nice sleep tonight, everyone.
Okay.
Have a nice day.
Have a nice day.
Okay.
All right, take care.
Bye-bye.
Thank you again. Bye-bye.
Bye. Bye.
Goodbye.